Hey everybody, John here from Make Math Moments, and I've got another video for you on some algebra techniques on how to teach that, and also if you're a student here, you're watching how to say, complete the square with algebra tiles, and the algebra tiles is the way to visualize it in your head, and it's like when I started teaching completing the square, students would say, okay, uh, what step do I do when, and why do I have to half this, and then I have to square this? Like, there were these complex steps that you're like, well, this just works. And when I started teaching completing the square using algebra tiles and through the area model and visualizing it, I had students completing the square in their heads. And that's when I was sold on using algebra tiles as much as I could to do any sort of algebraic technique. So in this video, I want to show you how I teach completing the square with algebra tiles. Well, before we do, I just want to remind you over on YouTube here, hit the subscribe button if you're watching this anywhere else. Also, hit the notification so that you know when we have a live video, like this one is going live right now. So I'm just going to jump right into a couple of examples on completing the square using algebra tiles. And if you have not yet seen my previous video, you're going to want to watch that first, because that's about factoring using algebra tiles. Let me see if I can bring that up right here on the screen background. Here we go. Boom, right here. Right here. So how to teach factoring with algebra tiles. This is the one you might want to watch first. It kind of goes into like how I sneak in factoring. I kind of hint on the idea of completing the square in that video too, but this video is all about completing the square. So let me dive in right here. I'm using Brainincamp, which is my favorite tool to use algebra tiles or display algebra tiles. Now, if you've got physical algebra tiles at your school or in your classroom, go ahead, use those. I throw those out on the desks for students to play around with. I demonstrate using Brainincamp. And if you're teaching remotely, like I am right now, I'm hooking my kids up with a license so that they can access that. You can set up your own license for your school once you get your Brainincamp license. Okay, so let me get into this. So I got two examples set up here. Let's say I had to complete the square on x squared plus 4x plus 4, and I had to rewrite this from standard form. If we put y equals here and put a quadratic expression into this, and then we said, hey, let's rewrite this in vertex form. We want to complete the square here. So to complete the square, the easiest way to think about this is you're actually going to make a square. That's all you say to the kids. This is how I snuck in factoring. I would give them the tiles in standard form and say, hey, you got an x squared term. Oops, that's in minus x squared. Let me get rid of that one. Let me just delete that one off of there. You've got an x squared term. You've got 4x terms. 1, 2, 2. And then I'm going to double those just to speed that up. 4 x's, and then I got 4 singles. Now, if this was like my other video on factoring, and it was just any expression, I would say make a rectangle. And I would say that too. You can make a rectangle here, or in this case, we want to make a square. And so if we can make a square with these tiles, you will find that you have just completed the square. That's the beauty of the visualness of completing the square. And so what I'm going to do is I'm going to take these tiles, and remember that when you're referencing the tiles with your students, you want to reference lengths. That's how you're going to rewrite this expression in vertex form. Is remember that this area is covering x squared units of area, and this length here is x, and this length here is x as well. So x times x creates an x squared area, and this algebra tile here, the x algebra tile is referenced, is length x. That's why these match up. And this is length 1, and that's why these match up. So if you reference lengths over and over again, that will help your students rewrite these in the right format once you're ready, once you've made your square. All right, so how do I make a square? Like, a square has to be symmetric, right? Like, same length on each side. So kids will play around with this. Like, don't show them how to make the square. Let them make the square. And then you just say, now, what's the dimensions of that square? And so kids will play around with putting x tiles, on different sides. They might say, you know what, I'm going to make these here, and then I'm like, okay, well, that's a rectangle, and then where do I put these singles to make the square? So they might play around with it, and you might push them to say, hey, that's not a square. Let's make a square. Okay, well, if I put one here, I've still got a rectangle, and I want to use all the tiles here. I want to use the tiles to make a square. Like, that's a rectangle. That's not a square. Okay, well, maybe a student will show you, hey, I'm tapping that, but it's not coming up. There we go. And I'm gonna rotate that one, and now I've got, notice, a square building here because this dimension is the same as this dimension. It's now symmetric on both sides, and if I can fit these in here, boom, I've made a square using those tiles. Here is the beautiful part. You ask your students to write the dimensions of that square, and you'd say, okay, well, this length here is x units long because it's x by x to make x squared. This is 1 and 1. So this whole length here is an x plus 1 unit, or sorry, length. And then this one is also, since it's a square, this should also be the same length, right? That's x, x plus 2. Why did I say x plus 1? I don't know. So we got x plus 2 up there, and then I've got x plus 1, and that's x plus 2 as well. And so notice the dimensions of this square is x plus 2 times x plus 2 as to capture its area. And so if these tiles captured the area of the area that's covered by the tiles, so does this. And so I can say, hey, you know what? I can rewrite this area covering by x plus 2 times x plus 2, or x plus 2 squared. I've made a square. And that is the beautiful part, is I've just converted that one into that format by making a square. Okay, so we've got that conversion. I just completed the square on that. Same thing on this side is if I had x squared plus 6x plus 9, you could have your students draw it. Oh, that's another way to kind of move towards some abstractness, and we'll get to another video in another day that does that. If you kind of say, like, you know what, if you didn't have enough tiles to do this, we could draw the area model and say, you know what, I'm going to put a square, x squared in this corner, and then I got to split these 6 x's up equally to make a square. Like I had 2 this way and 2 this way. They're going to play around with that again, and you're going to put, well, I'm going to need 3 x's across this way, like 1, 2, 3 across this way. And then to make a square, I'm going to need 3 across this way. And there's a total of 6 x's. And then look, I can fit, that's going to create a 3 by 3 grid of singles in here, and those 9 fit in there perfectly. I've used all the tiles. And so what are the dimensions here? An x plus 3 this time, and an x plus 3 again, and this is an x plus 3 all squared. And I've just converted this format into this format by completing the square. And I'm just using algebra tiles. But you're going to say, hey, John, but wait, that was easy. Those are both perfect square trinomials. Let's come on. We got to do a little bit of, hard stuff. Give me a harder one, John, like to demonstrate completing the square with algebra tiles. So let's do this one. Let's say it's not a perfect square trinomial. I'll set this one up. I've got x squared plus 6x plus 5. And I've got my expression window down here. I'm just going to turn that off so that we can build this square out. That's it. Just build the square. So here, I got x squared. I have these 6 x's. I know I have to have a perfect square, which means it's symmetric on both sides. So I'm going to split those 6 x's into 2 groups. There's one group. There's the other group. And we want to take that and put them across this way. So here we go. We're going to put them around this way to make the lengths. And we're going to take these ones, and we're going to put them down here, but I'm going to rotate them, and I'm going to make my square nice and beautiful. Okay, so I've got my beginnings of the square, and you can clearly see, kids will tell you how many singles fit in here. And you can see, like, if I start putting in here, I don't have enough. So I'm just going to leave those out of there for a sec. You could fill them in, but I like to show this technique that you would have done if you were just showing them steps anyway. You can say, look at how many fit in there. You'd say, well, I have 3 by 3. How many are going to fit in there? 9 have to fit in there, right? Like 3 by 3, it has to be 9. So I have to actually add 9 singles. Add 9 singles into this space. Let me add 9 singles for a sec. So 1, 2, 3. I'm going to triple this, so I'm going to duplicate that. And then I'm going to duplicate that part again. I made 9 singles. Let me put them in a little box because that's the way they're going to fit in there. Notice they fit, those perfect 9 are going to fit in there. But you're going to say, look I can't just add those 9 singles in there. That totally changes the expression. I have to add what? This is that great teaching moment that you would say, why are you adding and subtracting the same number on both, or same number in the expression? Because you need to add 0 tiles. Like we need to keep the expression the same. So I'm going to add 0 tiles, which means I'm going to bring in not another 9, but I'm going to bring in its opposite. So notice that with 0 principal is bringing in 0 tiles. Now these ones fit in there perfectly. Beautiful. There's my square. Then I come over here and I go, okay, what do I got left? Let's just use 0 principal and all of these single up. And notice what's left. You write the expression on what's left. This is x plus 1, 2, 3. X plus 1, 2, 3. You made a square. X plus 3 times x plus 3. This is x plus 3 all squared because it's x plus 3 times x plus 3. And then what do you got? You got these minus 4 kicking around. And you've just converted this format into this format by completing the square. And when you do this over and over and over again, kids will start to visually complete the square in their head, or they're going to start drawing a little picture to complete the square instead of trying to memorize algebra steps. So are you guys, how often have you completed the square in this way? Like, I didn't learn completing the square using algebra tiles at all as a student, but I'm teaching it using this technique because it's so visual. But you're gonna say, John, but that was also easy. What about if I have negative numbers? If I have a -8, you're working towards that with your student. It's the same thing, okay? I've got these x tiles that have to kind of be distributed to make a square. Split them up into their 2 groups. There are 8, so I'm gonna split them into 4s and 4s. And I do the exact same procedure. Make the square, make it symmetric, and then what we'll do is we've got x tiles that we'll just have to write our dimensions a certain way. Like, look at the dimensions. The x tile is of length x by -1. And so I've made my square. Look, I just have to fill in. Like, this is the thing you'd say to your students, like, what completes the square? What completes the square? We're going to put that number in here. But before I do, I want to show you this difference with the negatives when you're looking at writing the dimensions. Like, this length is x, and then because that area is a minus x, this length is a -1, a -1, a -1, and a -1. So this length up here is x minus 4, and so is this because we made it a square. This length over here is x minus 4. And when you start to fill in the square right here, you need to have -4 times -4. What is that? That's a positive 16. I need 16 single tiles to complete the square. So I'm going to bring in the 16, but then I got to bring in its opposite because I can't just bring in 16 and change the expression. Okay, so give me a sec. Duplicate. Duplicate. Ah. Had it there. Oh no. Give me a sec here. Let's get these all sorted out. There we go. Here's my 16. All right, so I brought 16 in. Now let me bring in its opposite. There they go. All right, these 16 fit in here. Boom, I've completed the square. And now what do I have left? We just used the simplifying up over on this side, and we've got, hey, what's our expression? I've got, let me write it up on the board here so you can see it. I've got x minus 4 all squared. That's what that area is right there. And then I got minus 16 and minus 2 more. And that's really you brought in, right? You brought in 4 squared, and then you had to subtract 4 squared. That's where this minus 16 comes in, and then I got to combine it now with my leftover. It's kind of like you push this to the side, you say, hey, let's make the square. We'll worry about that some other time. And we're worrying about it right now. We got minus 18 right here. And so we've just completed the square on this expression to convert that format into that format. So you do that one a few times, then you're going to say, John, but wait a minute, you've just done every one where the A was 1. That's easy when the A is 1. Well, what do you do when it gets a little bit harder? Like, how do you teach kids when there's a 2 there? I'm glad you asked, is because let's do one. How do you do it when there's a 2 there? Here is the idea when there's a 2 there. This means you've got 2x squareds. Just build 2 identical squares. There's 1. There's 2. Let's build 2 identical squares. And so what do I got? I got these 8x's, these minus 8x's. Now I have to distribute minus 8x's into 2 identical squares. So each square is going to get 4 x's. Okay, so there's 4 x's for this square and 4 x's for this square. And the 4 x's from this square, since I'm going to make a square, now have to be split into 2 because I need to have this symmetry. I need a square here. So let me get this symmetry going. Good. Okay, so the good. Now I need this identical square with this x term. Now, as I do this, if you're doing this and your coefficient of x squared, or your leading coefficient there is 3, then you build 3 squares. If it was 4, you build 4 squares. That's all the difference. Okay, so that's it. So it's like, boom, I've just made 2x squared, 2 squares that are identical. Okay, well, I could start filling these in, but I'm not going to have enough. So let's just complete the square on each. Well, I need 4 here, and I need 4 here. That's going to help complete my square. Oh my gosh, somebody's calling me right now. Give me a sec. That is so embarrassing. All right, so I'm making my square. I've just added the 4 in and the 4 in. And you know you're going to add 4 here and 4 here, which means you're going to have to add 4 of its opposites and 4 of its opposites. So right now I'm adding the 8, but I have to bring in 8 opposites. But let me just do that one at a time here. So we're going to go 4. I'm going to make a grid of 4 right here. Make this real nice and pretty for you. So there's 4 I'm going to fit in, but I'm going to bring in its opposite right away. Okay, so I'm just going to switch these to the opposite. So that's going to complete this square. And we're going to do that all over again for this square here. And so these are fit in my perfect square. I've just completed my square. I've got to do that twice because I have 2 squares. And now what's left? I've got 2 squares with a whole bunch of leftovers. So how do I write this expression? Right? How do I write this now expression? Well, you have 2 of those things. Well, one of these things is x minus 1 minus 1. This is an x minus 2 by an x minus 2 square. There's 2 of them. Write it like this. 2 x minus 2's squareds. Now I just need my last term, which is the combination of these. And so you can use, oh my goodness, that just looks silly. Now you can combine those up using your zero principle or subtraction, right? You got minus 8 plus, what do we have here? 1, 2, 3, 4, 5, 6, 7. Here we go. Let's combine these up. There we go. Oh, it didn't go away. Go away. Make it 0. Make it 0. And we get minus 1 left. And so in my expression, I'm going to add, hey, I've really got minus 1 left over here. Look at that. How visual that is. Look at how we did that. We completed 2 squares. So as I said, if that was a 3x squared up there, you'd build 3 squares, and you've just completed the square using algebra tiles. But then you'd say, hey, John, wait, what happens if that middle term isn't a nice even number like 8 where you can divide it by 2 twice? Well, great question. Come back. That's my video I'm going to do later this week. Check it out. And if you're already watching this after the live events, you should be able to see it on our YouTube channel. So go over and check out the YouTube channel, and you might be able to find that video. I'm doing that a little bit later. How do I do it when I've got this uglier number? We're going to split that up, and we're going to start using an area model to draw it all out, but still all visual. Before you go, I just want to show you an activity that Cal Pierce and I from Make Math Moments built to kind of bring out the area model and algebra tiles and completing the square. It's over on tapintoteamminds.com, and we call this one the magic rectangle task. This magic rectangle task. I wanted to show you this. Here it is. The magic rectangle task over on Tap Into Team Minds. This task originated, Kyle and I built this task driving home from a conference in the car, and we built this task with this one main problem that many, say, calculus teachers would know, or say algebra teachers would know. Is that common problem? It's like someone is selling tickets to an event, and the tickets cost this, and they're going to sell this many tickets, but then they say, well, for every increase in ticket price, the number of people that are going to come is going to decrease by this much. And now you have to figure out what is the maximum ticket price, or what is the number of tickets you sell to generate a maximum revenue. And that's what this task is really about. Like, that's the same expectation. However, we start with kind of just showing this rectangle and how this rectangle is growing or changing. And we ask kids to notice and wonder out loud. And then once they notice and wonder, we start to show them a little bit more information that, hey, we got some dimensions. And for every increase of width by 5, the length decreases by, I think, 2. And so then kids will start to make tables and charts, and they're starting to see what happens as the areas change, as dimensions change in the areas. And eventually you can generalize what's happening here, and you can make this algebraic expression. And then you have this great moment to complete the square with algebra tiles. So check that task out. I put that in the links in this video. Go ahead and look at that. If that is, if you're teaching completing the square, this is a task you definitely want to give it a go. It's so connected. And notice there's a video explanation of how to do this when you had, say, -10 x squared as the leading coefficient. So come back next time, though. I'm going to show you how to do it with fractions and some uglier numbers. And looking forward to seeing what you do. Let us know. How do you teach completing the square? So